Hey guys, welcome back to ATO Audio. Today on the channel, we're going to be taking a look at this Pioneer SX-1280. And so on a previous short, I showed you guys that someone did kind of a half-butt solution because they didn't have the right resistor or because they were just lazy. And because of that, the resistor came loose on the power supply board and it was causing this receiver not to work. So I went ahead and did a temporary fix on that. But today we need to go ahead and permanently fix that so it's not going to be an issue anymore in the future. So what I've done is I've actually ordered the correct resistor, and I've ordered it in this mounting hardware tool. Basically, I can mount this right to the frame of the receiver. It'll remove that resistor away from that power supply board and protect that board from any further damage down the road. And so they've already removed a couple of the transistors to the frame that overheat. And so now we're going to remove that resistor. So this thing is going to be in really good shape moving forward. And so without further ado, let's go ahead and come in a little bit closer and I'm going to show you guys what I'm going to do. All right, so as you can see, these are the two resistors that whoever worked on this before piggybacked on top of each other. And these are both 8 ohms. And when you put these two into parallel, basically it turns this 8 ohms into 4 ohms. And so originally this power supply board called for a 3.3 ohm resistor here. And so like I said before on the short, the person probably didn't have the correct resistor because this isn't a resistor most people would have. It's a 20-watt resistor at 3.3 ohms. So I'm assuming this person probably had the cement resistors that were 8 ohms and figured he could put them in parallel, get them to 4 ohms, and that would be close enough. However, he did not compensate for the additional weight of this, and this actually detached from the solder point on the back of this board, and it was causing this receiver not to actually power up or be operable. They did some good work here and they relocated these transistors to the frame here. However, this was a shortcut and just half-butt work, and so we're going to fix that today. And so what I've done is I've purchased the correct resistor, a 3.3 ohm resistor, and a 25-watt package. And so this thing is really a lot more robust. And what we're going to do, guys, is I think I'm going to mount it to the frame like right around here. And so in order to do that, we'll obviously have to run some wires from where these resistors are over here to plug into the resistor over here. But we're also going to have to drill a couple holes here in the frame so we can mount it. The good news is that the outer case is obviously non-electrical, non-conductive, and so we don't have to insulate this. But this is going to just be really, really super effective at removing the heat from this power supply board into the chassis where it can't really cause any harm. So I need to flip this over and make sure there's nothing behind here, and that's going to cause an issue. If not, I might have to find another location. But this is kind of what I'm going to do. So what I'm going to do is flip this over, guys, take a look to make sure there's no issues. If there isn't any issues, guys, I'm going to drill 2 small holes here, and then I'm going to get my tap and die set, and I'm basically going to thread these holes, and then that way I can use the same screws that we're using for the resistors. I think they're M5 screws. And then we can mount this, guys, plug it in, and this thing will be good to rock and roll. So let me go ahead and do that and take a quick look at the other side of the receiver, and then we'll come back here in just a second and start on this. So I've flipped over the receiver, and we do have enough clearance, I think, so I'm going to go ahead and mount that resistor right here. So before I do that, guys, I need to mark out where my holes are going to be. So I'm just going to hold the resistor up to kind of about where I think I'm going to do it at, and I'm just going to put a mark with this pen, a permanent marker, I guess I should say. Then, oops, that way I can get my 2 dots. And then I'm going to take my punch, and this is very important because you don't want your drill bit moving on you. And I'm going to miss completely like that. So let me do that again. There's one. And there's 2. So I'm going to be very careful when I drill these holes out because I want to make sure that I'm accounting for the metal shavings. I've kind of got it tipped on its side and there's nothing electrical underneath it really other than these transistors. So I'm hoping that the shavings kind of go down there. But before I obviously power this up, I'm going to blow it out and make sure all the shavings are out. So I'm going to very carefully go ahead and start my drill and just slowly start drilling and try to make sure the drill bit doesn't move on me. Which I'm having a hard time doing. I may need to start with a smaller drill bit first, so let me get a smaller drill bit and start with that first. This is pretty thin metal, so I don't think I need necessarily a lubricant. But if you're doing thicker metal, you may want a lubricant. And see, this drill bit's walking on me. Yeah. So guys, we're going to have to go to plan B, and plan B I don't have a plan for yet. So let me think about how I'm going to do this. I may just need to make a bigger indentation in this metal. Alright, so I just did a couple more knocks with that, so maybe that'll help my drill bit stay steady here. Okay, that seems to be working, so that's good. Now we just got to get a hole in it. Alright guys, so there's our first hole. I'm going to go ahead and do my second hole. Need to be very careful because I don't want to catch this string. And that's going to be almost impossible. So let me get something to kind of pull that string out of the way, just to make sure we're not going to run into any problems there. So I've got this wire here with an alligator clip on it, so I'm just going to grab it. And we'll just kind of clip it off to something else here over here on the back. Somewhere maybe. We're going to do the same thing here and make this hole a little bit bigger, or this indentation a little bit bigger, so the bit doesn't move on me. Maybe one more time. Now we'll drill our second hole. Don't have a lot of room here, so it's going to be interesting. I may have to get my other drill. Let me get my smaller drill real quick. See if I can make some room. I got my smaller drill now, so I don't know if that's going to give me enough leeway or not. The only problem with that is that it's not as powerful, so it may take longer to drill this hole. And so slowly but surely it's going. I may want to get a drop of oil on this bit. So I'm just putting a little tiny drop of oil on the bit. Taking a little longer than I'd like. You know, and maybe one screw will be enough to hold this down. I don't know. There it is right there. All right, so that's 2 holes. So now we need to step up to the right size that we really needed at, now that we've got the hole started. And this is the hole that I'm really need to make sure is right. That went pretty smooth. There we go, guys. So we got both of our holes are drilled. Now I'm ready to get my tap and die set out, and we can go ahead and start that. So let me grab that stuff, and then we'll meet back over here and tap these holes. All right, guys, so I'm back. I've got my proper tap size here. But the problem I'm going to have is that this is the handle for it, and so I'm not going to be able to really turn this. So one of the things when you guys start working on your equipment, especially when you're making modifications or really improvements to try to protect it and extend the longevity of the receiver itself, you're going to have to improvise. So I was hoping to find a socket that would kind of fit on that end here of the tap, but I couldn't. So what I'm going to wind up doing, guys, is just basically taking a needle nose vice grip, clamping it, and then using that to turn. And I'm going to want to try to be as straight as possible. Now this is really thin metal, so it's not going to take a lot. So I think with a little oil on the end of my tap, I think I'll be fine. So I'm going to go ahead and do that. So y'all wish me luck. We'll put a little oil on the end of it. And we'll see if we can't get these holes tapped. You want to try to keep it as straight as possible. And then after you turn a little bit, once you get started, it'll straighten up itself, as long as you're not really, really crooked. Now I'm not putting a lot of pressure on this. I'm just kind of taking my time and going slow, waiting for it to catch, and letting it do its thing. Like I said, this is thin metal, so it's not taking a lot of effort, but I know there's a circuit board behind there, so I don't want to try to He-man it. And then every once in a while I'll screw out. I'm just going to take a peek at it, and we're getting threads, guys, so that looks good. So let's see if let's put a screw in there and see how it's working. And it doesn't look like it's working good because I can't start a screw. So maybe I haven't got enough threads cut yet. Or maybe I'm just doing a very bad job at doing this. So let me apply a little more pressure in there. There we go. You don't want to rush this, guys. You want to take your time and make sure this is right. And at first it'll give you a lot of resistance, but then it'll start turning pretty freely, and I think I'm there where it's turning freely now, so I think I'm all the way through. So I'm just going to back out. All right, so it looks like we've cut all the way through, so let me try that screw again and make sure the threads are good. And this time, threads are good. So now I'm going to repeat that process on the second hole here, guys, and if that goes well, we'll be in good shape. All we'll have to do is just connect the wiring. I'm going to see if I can go all the way through this screw. I may use a shorter screw than this one just to make sure I don't make any contact with the circuit board below. But we're in good shape, guys, so that's working nicely. So I'm just going to kind of wipe the threads off here. Put a little bit more oil on there. Doesn't have to be a lot, just a little bit. Just going to put a little bit of oil. And then we're going to go for the second hole. All right, starting to get easier now. There we have it. So I'll back it out. We'll test it with the screw, and if that's the case, we're ready to put our resistor in there. I've been really careful not to make sure I'm going too far into it, and I'm kind of keeping my area clean, make sure I'm wiping off the threads. Let's go ahead and test our screw out. And just like that, guys, we've got 2 threaded holes. So now we're ready to install the resistor. I'm going to go get some shorter screws and we'll be right back. All right, so I found my shorter screws, so we're now ready to install our resistor. And I don't know if this will be installed permanently or this will just be kind of giving me an idea to get my wires lined up. It's kind of a pain in the butt with being able to hold this in place because I wanted to give you guys a good camera view. So I've got it on its side so you guys can get a really good view of this, but trying to hold this up at the same time with this and film, it's kind of a pain in the butt. So I hope you guys appreciate it. Of course, trying to find the holes always gonna be a problem, right? But there we go. We've got that one in, so the next one should hopefully be a little bit easier. Hopefully. And just like that, we've got our resistor mounted. And this is a 3.3 ohm, 25 watts. So it's actually higher rated than what the original one called for. And it's mounted to the chassis. So all we have to do now, guys, is connect it to the board. And so I'm just going to fabricate some wiring for that. I'll probably put in a some kind of connector here so it can be just quickly disconnected if we ever have to service this board in the future, without having to desolder the wires per se. You can just disconnect them. So let me go ahead and change orientation so we can do that, and we'll be back in just a moment. All right, guys, so I've gone ahead off camera and I've fabricated my wiring to do this, and I just used some silicone wire that I had, and I tinted it already with some solder, and I put on these connectors, and so these are just going to slide over the ends of the resistor. And so then we'll just route the wires down to the board. Now, I need to go ahead and cut this strap, which is kind of just supporting these. And then I'm going to, they've got little plastic grommets here on each side of the board. I'll probably go ahead and remove those, and that'll give me a little bit of space to pull the board out a little bit. And then I'm just going to heat up the 2 attachment points for these resistors. That way I can get those resistors off. I don't really have to completely remove this board or anything, so I'm going to try not to. And then I'll basically just solder these wires in, just kind of route them up here, attach them to the resistor, and we should be good to go. So let me go ahead and do that now, and we'll get started. So first thing, I'm going to go ahead and just cut my temporary zip tie. What would we do in the world if we didn't have zip ties? And you can already see that I was giving it some support. And so now I need to get these little grommets out. And so these things can be a pain in the butt sometimes. So let's see if I can't get lucky and get on a lip here and pull one out. And so there's the first one. These are super small and easy to misplace, so make sure you don't lose them. Once you do that, you can kind of just pop out this centerpiece, and I'd set that off to the side as well. We'll do the same thing for here on the bottom. And as you can see, that board is now loose, and that'll just give me a little more leeway to get my solder gone in here and disconnect those resistors. So without further ado, let's see if we can't heat this up and get that first. And that was super easy. It was barely in there, so that didn't take any effort at all. And just like that, we've got these two cement resistors out. And so that one just basically came right apart too. So this was a time bomb, guys, waiting to happen in this receiver. So, you know, it's a shame whoever did do some of the work on here, looks like they did do some really good work, and it's a shame that this was the weak point in this repair. So these are perfectly good, so I'll probably save them and use them for some other project. But let's go ahead and get our wires in now and put a permanent solution to this problem. So this doesn't have to be fancy. There's no polarity on the resistor, obviously, so we can just solder these in. Get a good amount of solder on them. Make sure they're attached really well, just like that. And this has got plenty of solder on this side, so I won't have to add any. And we'll just make sure that I get it embedded really well. And that's all there is to it, guys. So now we can reattach this board. I'm going to do some loop-de-looping here. Run this up behind these other wires here. You know, doing some of these repairs, guys, is a pain in the butt sometimes, but doing some of these repairs while you're on camera is really a pain in the butt sometimes, because you're trying to make sure you stay out of frame while trying to do the same repair that would have been easier and 10 times faster if you could just be in the way of the camera. So I'm trying to do this while you guys can still see. You know, and what I'm going to do, guys, is I'm going to take this back out and I'm going to attach the wires, and then I'm going to put it back on. I think that'll be easier for me than trying to get my big hands in this tiny space. So we'll do that first. That'll make it a lot easier. So here we go. There's one. There's two. And now we can put it and mount it right back where we had it. So let me get my screwdriver, my screw ready. Ah. Oh no, now I done lost my screw, guys. Did y'all see where it went? If you saw where it went, leave a comment down below. Aha, I found it. Were you right? Did you find the screw? And just like that, guys, we have our permanent repair. The wires are all tucked out of the way, so we'll go ahead and reattach this board. Maybe slide some of this extra slack of the wires back behind the board that we don't need. And then we'll be ready to power this back up and test it out. So let me go ahead and put these grommets back in. This is going to be the hard part here, is getting the plastic grommets back in. There we go. There's the bottom one. Now let's do the top one. All right. Everything's good, guys. I'm going to go ahead and set this back up. We'll do a test on it, make sure it's working. So let me go ahead and change the orientation and we'll be right back. Okay, so we just got done doing the repair. I've gone ahead and cleaned up the unit, made sure there wasn't any metal shavings in there, blown it out, and we're ready to go ahead and power it on. So if you do this type of repair, guys, obviously since we had to do some drilling or whatnot, there could be metal shavings or whatnot, so I'd always be worried about a short. So I did do a good job. I ran a magnet back there, I blew it out, so I don't think we have any metal shavings. But just to be on the safe side, guys, I plugged it into my dim bulb tester, so when we power this up, I want to make sure there's no shorts, because if there is, I want to be able to quickly power it down, identify where that short is, fix it, and then go from there. I don't want to make sure that a simple repair like this turns into a major repair because I wasn't paying attention. So I suggest you guys do the same thing as well. So we've moved that resistor off the power supply board now, guys. We've done it right. We've sized the correct resistor, a 3.3 ohm resistor, and we've upgraded it to a 25 watt, and it's the one that has the kind of the mounting hardware, and it's going to be on the chassis, so it won't be a heat issue anymore for this Pioneer SX-1280. So without further ado, let's turn this thing on and make sure that we don't have any problems. So there's my dim bulb, and as you guys can see, it's quickly gone out, and we just got relay click, I think. So I'm going to go ahead and hit play, and let's see how it sounds. All right, team. Well, I think that's a successful repair. Now this Pioneer SX-1280 will be faithful for years and years to come. And so hope you guys enjoyed this content. You know, sometimes when manufacturers do these, they make these receivers back in the 70s, guys, heat was a big common issue with these receivers. So by moving those transistors and finally this resistor off that power supply board, it's going to make this thing work a lot longer and add that longevity to it and not have heat as an issue. I can't tell you, and if you guys have been watching the channel, heat is a big enemy of these units. And so probably something else I'll do, guys, is I'm going to go ahead and install the feet that I make. And if you want to find these feet, guys, they're on my website, ataudio.com. And these feet are about 6 millimeters taller, and that allows for greater airflow under the unit to make sure we get some of this heat out. So if that's something you guys have not done to your units, I would highly recommend doing that, because like I said, if you've watched my videos, you know on a lot of the repairs that we're doing, guys, heat was the ultimate culprit, you know, especially on some of these power supplies with a Pioneer. So if you want to, go to my website, ataudio.com, and purchase a set of feet. They're taller. If you guys have any custom feet requirements that you want, if you want even taller than what I'm providing, just let me know. Send me an email and I can make it. I just had someone reach out to me the other day and they wanted something very, very thin for a unit they were doing, 5 millimeters, and I was able to accommodate that and print out custom feet for them. So without further ado, guys, thanks for watching, and we'll see you on the next video.